Okay, how are radiometric quantities related to photometric quantities? So they are related through the luminous efficiency curve, the one we just saw. So 1 watt of radiant flux at peak wavelength of 555 nanometers, where the luminous efficiency of the eye is maximum, equals luminous flux or power is defined to be 685 lumens, LM. That's not 1, that's L. Lumens. So now we're going to relate these quantities to each other. So a photometric unit is defined as K as a function of lambda times a radiometric unit, where K of lambda is 685 times V of lambda. And where do I find this V of lambda? So write this down and I'll show you how this is done. That's the efficiency from the curve, this one. So if you look at here, that's V of lambda. That's not volume, that's the efficiency. Okay, so how do I convert radiometric unit to photometric unit? So I'm gonna do a line here, and I'm gonna write on the top here and what color do you want for your photometric unit? Blue. Blue. Okay, now can everybody take out your notes from last time and tell me what was the first radiometric unit we used? Radiant energy. Do you remember the symbol? And the unit? Corresponding to this radiant energy, the photometric unit is luminous energy, is Q subscript V. And its unit is what we call Talbots. Number 2. Radiant flux. Radiant flux. And it's also called radiant power. And what's the symbol for it? IE. Yeah. And what was the unit for it? And the formula? QE over delta T. Very good. So equivalent photometric unit is called luminous power, whose symbol is phi V and whose unit is lumens. which is also Talbots per second. And this is 5V equals dQV over dt. So in most of the textbooks that I was looking for, they don't call it small d, but they call it delta. I'm not sure exactly why they do that. So I'm going to change this to delta. Delta QV over delta T. Number 3, part A of it was called radiant exitance. What was radiant exitance or emittance? Exitance reminds you of exit, which means leaving, which means that's the energy from the source, right? Leaving from the source. What was the unit for it?
Watts per meter squared.
Watts per meter squared. And the formula? Over dA, where this dA is the area of the, very good. This is the area of the source. The equivalent for photometric units is called luminous exitance. Its symbol is MV. Its units are lumens per meter squared, which is also sometimes called lux. And the formula will be MV equals delta phi V over delta A. Where again, this delta A is the area of the
Source.
woohoo. 3B. Irradiance, right?
Yeah.
And the symbol for it is EE. And the units again are watts per meter squared. And the formula is EE equals d phi E over dA, where this time irradiance is the area of the target. Yeah, so this is the area of the, I want to say target. The equivalent photometric unit, 3B, is called illuminance. Its symbol is EV. Units again are lumens per meter squared or lux. With a formula, A. And again, this is the area of the target, the eye, the detector. I'll leave this here. Number 4. Okay, number 4. Radiant intensity. IE. And the units were watts per the equivalent in photometric units is called luminous
Entity.
Yay! Do you see a pattern developing? What do you think the symbol is?
I'm gonna go with IV.
There we go. Remember vision, V, photometry, I, lumens per steradian, which is also called candela, or CD for short. And the formula for this one would be IV equals delta phi V over delta omega. Number 5, radiance.
I don't know if I'm eradicating what I'm doing. It's got 2 points.
What's the units for this? Anyone?
Watt per meter squared times the radius.
Thank you. And the equivalent for photometric units is luminance. LV. LV formula will be delta squared phi E, no, not E, V, right? Phi V over delta omega dA cosine theta. And the units for this one will be lumens per meter squared steradians. I think this is a table worth making.